Hello, folks. So one of the things that we wanted to do was to give you the opportunity to see how this idea of impedance and reactance sort of plays out in a real live running AC circuit. So I'm going to hook up for you an RC circuit, and I'm going to pipe in 1 volt peak to peak at 50 cycles per second, and we're going to take some measurements. And then we're going to let you do some calculations to see how things go, see if the theory actually bears out. First thing we need to do is to figure out how big the capacitor and the resistor are in the circuit. So we're going to use the impedance bridge. So it is on and it's currently set to resistance. So I'm going to go ahead and put it across the resistor that I will be using. I have the circuit board here, you can see. And it seems to be measuring a resistance of 32.8 ohms. So that is one bit of information that you're going to need. R of the resistor is 32.8 ohms. Now I'm also, once the circuit is all set up, I'm actually going to go ahead and measure what the resistance is across the leads going into the power supply, because there's wire in the circuit and that has resistance to it also. And so I'm going to want to know what the total resistance is, resistor-like resistance is. As far as the capacitor goes, we're going to be using this capacitor here. I'm going to put this on capacitance. And it appears as though it looks like we have 87.7, and we are in the microfarad range. So the capacitor that we're using is 87.7 microfarads. All right, so we're pretty much done with the impedance bridge. We have the information that we need. I'm going to go ahead and put it aside just to kind of get it out of the way. And now what I want to do is to go ahead and actually hook up the circuit. So I'm going to go from the power supply to an ammeter because I'm going to want to know what the current is flowing in the circuit. So here I have a meter that's set for measuring current. I'm going to go in the high voltage side of the ammeter. From there, I'm going to continue on from the common, and I'm going to go to the resistor that we're going to use. Okay. From the resistor, on this side of the resistor, I'm going to go over to the capacitor. Okay, this is the capacitor we're going to use. And then the capacitor is going to go back to the power supply. So this lead is going to hook in the other side of the capacitor. So at this point, what we have is our circuit, our RC circuit, with an ammeter hooked into it. Now, we want a couple of voltages in this whole thing. Number one, we want to know what the voltage is coming out of the power supply. So I have another voltmeter here. And I'm going to go ahead and I'm going to hook it across the power supply, like so. Turn that on, turn that on. And we'd also like to know what the voltage is across the resistor. So if you remember, the voltage across the resistor is proportional to the current through the resistor. And so that would be something that would be kind of nice to know something about. So this is the, where am I? This is the high voltage side. Hold on a second here. Oh, oops, wrong guy. This is the high voltage side of the resistor, and this is the low voltage side of the resistor. So this is measuring what the voltage is across the resistor. This is measuring what the voltage is across the power supply, and this is measuring what the current is through the circuit. So I'm going to go ahead and turn this thing on. I preset it to 50 cycles per second, and I'm hoping that you can see that that's actually what it's set at. I'm additionally going to go ahead, just for the fun of it, and plug the power supply into this oscilloscope. So the oscilloscope is at 0.5 volt per centimeter. So this thing ought to jump 4 centimeters worth, and that's essentially what it's doing. So here is the 0 line. I'm up 2 centimeters for an amplitude of 1 volt, which means if you have a 1 volt amplitude, you would kind of expect the RMS value to be somewhere around 0.707 of that, which is somewhere around 0.71. And in fact, if you take the voltage reading off of the voltmeter coming out of the power supply, it's giving you a value that's pretty close to that. So I'm going to write that down. It's actually 0.732. So the voltage across the power supply is 0.732 volts. The voltage across the resistor, you can turn that voltmeter on. Come on, little guy, turn on. There we go. Oops, I just turned it back off again. It turns out that the voltage across the resistor, if you look at it, so it appears to be about 0.429. So this is about 0.429 volts. And the current, which is really pretty important, is 13.1 milliamps. So your current is 13.1 milliamps. And if you remember, I said the frequency was 50 cycles per second. Okay, so there's one other bit of information that we'd like to have, and that is what the resistance of the circuit is with the extra wires in. And so what I've done is I've taken the ammeter out because we don't need it for this, and I've disconnected the voltmeters, and I've simply taken the wire that is going into the terminals to the power supply, and I'm going to go ahead and put the impedance bridge across it. I pulled the impedance bridge in, and that resistance is measuring 33.4 ohms. So there's a little bit more, 33.4 ohms. So there's a little bit more resistor-like resistance in the circuit than just the resistance across the resistor, and you may very well need that information or not. We'll see in the write-up. But if you need it, you'll have it. So anyway, that's it. So you should have fun with this. You're gonna basically in the write-up, what you're going to be asked to do is to take the voltage across the resistor and the size of the resistor and calculate what the current must have been. And then you're gonna calculate the impedance, and then you're going to take the voltage across the power supply and put that equal to the current times the impedance, and you're going to see what that current turns out to be. And they should end up being about the current that you actually measured with the ammeter, which is this 1.13 milliamps. So, and if it's not, then apparently there must be something else going on in the circuit there. But in any case, it should be fun. It'll be interesting to see how it works out. So anyway, that's it.